Hi friends, we always rub our hands in winter season like this, and sometimes we touch our cheeks like this, isn't it? So what do we feel? We feel heat from our palm of our hands. So how it get heated? By mechanical work done by rubbing our hands, isn't it? Similarly, when two stones are rubbed together, then also stones get heated. This is also due to the mechanical work is converted into heat energy, and uh, from kinetic energy of gas, we come to know that due to the random motion of the particles of a gas, they collide against each other. Due to that collision, they exert pressure as well as there is energy associated with the molecule. That energy is called internal energy, and total internal energy gives us the expression of temperature. So we come to know that temperature is the measurement of the internal energy of a system. The system may be the system may be uh, the The system may be either a gas cylinder or a liquid molecule, or sometimes in case of a solid. So all of the states of matter uh, have internal energy in it, and those internal energy gives us the value of temperature of the system. Let us consider two bodies. This one. The red one is the hotter body and the blue one is the cold body. Okay. So the red body has large internal energy in it, and the cold body has a less internal energy compared to hot body. So when they brought, are brought in contact with each other, then the molecules of both the bodies start sharing their energies by collision. That eventually what happens, the hot body energy decreases, and gradually the energy of the molecule of cold body increases. This process will continue until the energy of both the system are equal, until the energy of both the bodies are equal. That means one of the hot body will decrease energy and another one will gain energy. So the total energy of internal energy of the molecules of the cold body will begin to increase. The process of transfer, the process of transfer of internal energy from one body to another, caused by the difference in temperature without doing any work, they are doing no work, without doing any work, is called heat exchange. And a state will be reached when there is no net transfer of internal energy from one body to the other. No one is exchanging energy. At this stage, the two bodies will be at the same temperature. When there is no transfer of internal energy takes place, then we can say both the bodies are at same temperature, and they will be said in thermal equilibrium to each other. What? They will be said in thermal equilibrium with each other. That means this red body has temperature T, then the blue body also has temperature T. So when they both have same temperature, we will say it as in thermal equilibrium. Let us consider three systems. This one is A, this is B, and another one is C. Okay, so when A is fitted with a system C, okay, A is fitted with a system C, there is there is a wall between A and C, and that wall is the diathermic wall. What do you mean by diathermic wall? Diathermic wall is that type of wall in which heat energy can transfer from one of the system to another, okay, from this system to another. So that type of wall through which heat energy exchange is possible, this is called diathermic wall. Similarly, system B is also fitted to the system C also with a diathermic wall. That means there is a possible energy exchange between through the wall of B and C. But A and B, A and B are separated by a adiabatic wall. What is meant by adiabatic? That means the wall through which no energy exchange is possible. No energy exchange is possible. So A and B are separated by adiabatic wall through which no heat exchange is possible, and both A and B are fitted with system C through a diathermic wall. That means there is possible energy exchange between A and C, also between B and C. So this is the system we have created. So as there is a diathermic wall between A and B with C, so there is exchange of energy until the temperature of A and C are same, until the energy between A and C are same. That means we can say that A and C are in thermal equilibrium. Similarly, the internal energy of B exchange remains until and unless the temperature of the system B is equal to the temperature of the system C. So until the temperature will same, there is a exchange flow of energy takes place, and after same temperature, attaining same temperature, uh, there is no exchange of energy between B and C also, then we can say B and C is also in thermal equilibrium. So now we can say that A is separately in thermal equilibrium with C, and B is also in thermal equilibrium with C. So as C is the common system fitted with A and B, as A and C are in thermal equilibrium, B and C are in thermal equilibrium, then we can say that A and B are also in thermal equilibrium to each other. Then we can say that A and B are also in thermal equilibrium with each other. So this is the zeroth law of thermodynamics. And the quantity which uh, shows that they are in thermal equilibrium, that is temperature. So temperature is a scalar quantity. Temperature is a scalar quantity, and it is measured in Kelvin scale, in degree Celsius scale, in Fahrenheit scale also. There are different number of scales for measurement of thermometer, but commonly Celsius scale, Fahrenheit scale, and Kelvin scale are used in day-to-day life. So equality of temperature is the necessary and sufficient condition for the systems to be in thermal equilibrium with each other. In Celsius scale of thermometer, the lowest measuring temperature is 0 degrees Celsius and there is 100 divisions in it, and the highest measuring temperature is 100 degrees Celsius for Celsius scale. Similarly, in Fahrenheit scale, it is 32 degree Fahrenheit is the least value that can be measured by Fahrenheit scale, and there is 180 divisions in Fahrenheit scale. So the highest temperature that can be measured by the thermometer of Fahrenheit scale is 212 degree Fahrenheit. And the mostly used scale is Kelvin scale. On this scale, the minus 273.15 degrees Celsius is taken to be a 0 Kelvin, unit is Kelvin. So this is the absolute zero of Kelvin scale temperature. So the relation between Fahrenheit scale and Celsius scale, as well as Celsius scale and Kelvin scale, is shown in this video. So now the question arises, at what is the temperature at which we get the same reading on both the centigrade and Fahrenheit scale? So here is the solution. Similarly, we can convert degrees Celsius into Kelvin, also from Kelvin to degrees Celsius, by using the relation between absolute temperature and Celsius relation. What is the temperature in Celsius scale if we take 0 Kelvin? So at 0 Kelvin, we have minus 273.15 degrees Celsius, and if we take 0 degrees Celsius, then what is the value in Kelvin scale? It is 273.15 Kelvin. For mathematical convenience, we can drop 0.15 value, so it is 273 Kelvin.